ASK Aviation School.
Good morning, ladies and gentlemen. Today we will talk about one of the most important chapter of our navigation that is also a part of your syllabus for DGCA, EASA, as well as the FAA, CPL and the ATPL exam. The name of the chapter or the topic is what we know as a Triangle of Velocities. So now, what is the importance of this particular chapter is that, let us assume that we have to go from place A to place B on the earth, that is flying from place A to B on the earth, and if I draw a line between the point to point, okay, this line which I draw onto the map or the chart, because I cannot directly draw onto the earth, and we use either a map or a chart inside the aircraft. So I will draw this line from A to B on a map or a chart. This line will now be known as the track required. And it will be represented by a two arrowhead like this. This is the track required. Now I can measure the direction with respect to the true north. Now in this particular example, it appears to me that it is 90 degrees, so direction will be 090. I know the direction, okay, in which I need to go, 090 degrees, okay, and I can measure the distance in terms of nautical miles, and let's say the distance is, let's say, 600 nautical miles. This is what I know. But now when I fly in the air, every moment my aircraft is subjected to a force, what we normally know, the wind force, the wind velocity. Now, the next thing what we require to know is that the direction onto which the fore and aft axis of the aircraft is pointing. Okay, that is the nose of the aircraft is pointing, or the fore and aft axis is pointing. Now at this moment of time, the fore and aft axis of the aircraft is pointing towards the north, and at this point of time it is pointing towards the east, that is 090. At this point of time it is pointing towards the south 180 direction and the 270 direction. The direction into which the fore and aft axis of an aircraft points is what we call it as a heading of the aircraft. So heading is the direction onto which the fore and aft axis of the aircraft points towards. Now, when the aircraft flies, okay, through the air, okay, the airflow is going to be going over the aircraft, or the motion of these air particles on my particular aircraft is what we call it as a true airspeed. Okay, or the TAS. True airspeed is the relative motion between my aircraft and the air. So that is what we call it as a true airspeed. So now, when aircraft flies, it will fly on a particular heading with a particular true airspeed. Okay, that is the relative motion between the air and my aircraft. Now, let us say that my aircraft starts from here pointing towards B, that is the track required is 090. If I fly with the heading 090, after some time, depending upon the velocity, I will arrive over at Bravo. That is what we assume. However, it will not happen like that. At all times, my aircraft will be subjected by the winds. Let us say that the winds are coming from this direction. Wind's velocity, okay, is represented by a line with 3 arrows. So if I do not correct for this wind and continue pointing towards 090, my aircraft will slowly be drifted like this, and I will land up somewhere here, right? So, and this wind velocity, I can find it out from the meteorology department. The meteorology department will give me the winds. Okay, now as far as the winds is concerned, the wind velocity is represented from the with a line representing the direction from where, I repeat, from where the wind are coming, and with the speed. In this particular line, if you see, approximately it is going to be about 030 direction. It is coming from 030 direction, and let's say the velocity is 20 knots. The speed is measured in knots. So I have got now three vectors. One is I have got the track required with distances. I know the direction on which my aircraft is going, that is heading, and my TAS, I get it, which is represented by a single arrow, and I have another vector which is the wind velocity vector, which is again represented by a line with three arrows. So now I have 1, 2, 3 sets of information. So now if we recollect our childhood days, we have learned something known as a triangle of velocities. Okay? In that, if my aircraft is pointing or flying on a heading with a particular speed, let's say this heading is going to be about 060, and the winds are coming from, let's say, directly opposite, and let us say this is from 060, it is coming, and the velocity is 20 knots, and this is heading, and let's say the TAS is 200 knots. My aircraft will now be impacted by this wind. So my aircraft velocity will be slowed down by this, because since they are in the opposite sense, my aircraft will still be traveling at 060 direction, and with a lesser, this is by 200 minus 20, my speed will now be 180. This speed which I am experiencing, okay, this is with respect to the ground, is known as the ground speed. And let's imagine that the winds are coming from directly from the backside. That is 240 direction, and if the speed is 30 knots, my aircraft will be pushed by the wind towards the direction in which I am going, right? So my aircraft will still be traveling at 060 direction, because it is winds are also coming from the same direction. So I will be going towards 060 direction, but however the speed now will be 200 plus 30, which is equal to 230, which is what we call it as a ground speed. While it is pushing me back, yes, in this example which is there with the white color, the winds are pushing me back. So then I will say that I will have a headwind. Okay, in this case I will say that I have a headwind. And if the winds are coming from directly from behind the aircraft, and I will say that I am having a tailwind. So in this case, in the previous case, the component of the headwind is 20 knots, and in the example which is written in the red color, the component of a tailwind is 30 knots of tailwind. Headwind of 20 knots and the tailwind of 30 knots. Now, let me put the thing together now. Then, once again, let's say that my aircraft is pointing towards this direction, that is heading towards this direction, which is 090, and let's say I'm moving with 200 knots of TAS once again. Heading and the TAS vector is always represented by a line with a single arrow. And let us say the winds are coming from 360, that is from the north, 360, and let's say velocity is 20. The speed is 20 knots. In this case, what is going to happen is there is no pushing ahead or no pushing back. Am I right? Yes? Now, the only thing is, if I continue flying like this, the wind will push me down in this direction. Am I right? Yes, push down in this direction. So I will remove this and draw the line here. The winds are coming from here. Okay, so now let us assume that if you fly for 1 hour, if you fly for 1 hour, the aircraft would have traveled 200 nautical miles because its TAS is 200 miles. Am I right? In this case, the velocity, wind velocity is 360 and the 20 knots. This is also in 1 hour. Am I right? So the wind will continuously push me throughout this 1 hour. At the end of 1 hour, my aircraft will be landed 20 nautical miles to the right of track, right? Isn't it? This is left of track and this is right of track. So my aircraft will land up right of track. Okay, my aircraft would have been following this path. Like the way when we swim on a river, okay, if I want to cross the river, the flow of the river will carry forward and I will land up ahead. Am I right? Likewise, the same thing will happen and my aircraft will land up here. Now, what have I done? I have constructed one vector which is heading and the TAS, another vector which is wind velocity, that is wind direction and wind speed, and now the resultant is what the aircraft is actually be following on the ground because of the effect of this wind. So this is what we call it as the track made good. And this component is going to be my track made good and the ground speed. This is the distance I have traveled from this place to this place in 1 hour. Am I right? So that is why it is known as the ground speed, the physical distance I have traveled over the ground. So in a triangle of velocities, triangle of velocities, we have one component, one vector, another vector, and the third vector. So these are the composition of the triangle of velocities. So now, why is it important? Okay, if I don't do any correction, I will land up like this. Am I right? So my aim is that once the Met department has given me the direction from which the winds is coming, what I can do is I can construct the same component of wind, that is 360, 20 knots up the track. Am I right? Yes, up the track. And instead of pointing my aircraft nose or flying on a heading like this, if I join this line and if I fly a heading of slightly less than 090, we will calculate it later on, but I have to stir a heading which is less than 090. For example, let's say 080 if I fly, okay, and my aircraft speed is still 200 knots of TAS. At the end of 1 hour, my aircraft, the winds would have pushed a little, and at the end of 1 hour, my aircraft would have landed up exactly at the point where I wanted to go. So why we need this equation or this triangle of velocities is to find out, okay, the track required now, because I want to go from A to B. This is now become a track required. I know the track required. Okay, this is the track required. And the distance I know. Okay, now my aim is to find out what heading should I stir, okay, to go from A to B. And if I am flying with a TAS of 200 knots, how much will be my ground speed, okay, and how much of time will I take in order to travel this much of distance. Am I right? Since we are drawing a component for 1 hour, 200 is also in 1 hour, 20 is 1 hour, the length of this particular arm, from here to here, if I have to draw, it is what we call it as a ground speed. That is the physical distance which we have moved on the ground. So this is now track and the ground speed component. So if you have a certain amount of distance which is given, okay, if your ground speed is let's say 200 knots, okay, and if you have to travel 600 miles, then I know that I will take 3 hours to fly from place A to B. So that is the basic idea of knowing this triangle of velocities. So now this is the importance of your triangle of velocities. Okay, with this we will end the video for today. Thank you, ladies and gentlemen. And if you are new to this channel, I request you to subscribe and share it to your friends. Thank you.
ASK Aviation School.